In this problem, we have some metal, and we're given its work function. The work function is how much energy is required to remove an electron from that material during the photoelectric effect. So what is the longest wavelength of light that can cause a photoelectric effect in this metal? So when you have the photoelectric effect occur, that electron that's being released has kinetic energy. That kinetic energy is equal to the energy of the photon that you started with minus the work function. So how much energy you had minus the work function that it took to remove that electron. That leftover energy is the kinetic energy. And we're looking here for like the longest possible wavelength, which is to say, what is the smallest possible energy that you could have for that photon? And so we're trying to find the starting point, meaning that really these two values are going to be equal to one another, that this kinetic energy is 0. So in that case, the work function is going to equal the energy of the photon, and we want to solve for wavelength. So to rearrange this, we're going to multiply by the wavelength, going to divide by the work function. All right, so hc, Planck's constant, times the speed of light. We have that value already combined, already converted to electron volts and nanometers. And then divide by this work function that we're given, 3.72 electron volts. So divide by 3.72, and I get the longest possible wavelength of 333 nanometers. And so that's to say, really, if we want to see some electrons produced that come off with some kinetic energy, we need a wavelength shorter than 333 nanometers.